sine, cos and tan of these angles keeps cropping up in work we do. So we need to be able to get an exact value for the sine, cos and tan of 30, 45 and 60 without using a calculator. And there are two triangles to be able to remember those. The first triangle is, if we imagine an equilateral triangle of side length 2. So that's 2, and that's 2. You know from basic geometry that this would be 60, and all the angles will be 60. If we now were to drop a perpendicular to this side from the vertex up here, and that was perpendicular, it would cut that top angle there in half. So instead of that whole angle being 60, that will be 30. It would also cut this side in half. So what I'm going to do now is just put that down as 1. And we're going to throw this away, this right-hand side of that triangle away. So we got 1, 2, and using Pythagoras, you know that this squared plus that squared equals that squared. You can play around with Pythagoras and find that that's equal to the square root of 3. Now, just by memorising that triangle, and that is one that you do need to remember, you can work out sine, cos and tan of 60 degrees and 30 degrees. I'll do that in a minute and put it in a table. The other triangle that is worthwhile memorising is a right angle triangle where you've got both sides equal to 1. So it is an isosceles triangle. And because that's 90 and these two angles must be equal to the same, they must both be equal to 45 degrees. Using Pythagoras again, you know 1 squared plus that squared equals that squared, so this one will be equal to the square root of 2. Now that will allow you to work out sine, cos and tan of 45 degrees. So if we were to put it into a table, so we got theta as 30, 45, 60 degrees. And we've got sine theta, cos theta, tan of theta. Now, the idea is not to memorise this table, but to memorise those two diagrams, and you can generate this table here. Sine of 30, okay, which triangle? It's this one here. Sine of 30 is opposite over hypotenuse, so that's equal to a half. Cos of 30, cos is adjacent over hypotenuse, root 3 on 2. Tan of 30, opposite over adjacent, so that's 1 on root 3. And it is common when you've got root 3 to multiply top and bottom by root 3 to get rid of a third on the bottom, and you'll get root 3 on 3. Numerically, those two are exactly the same. It's just a nicer way of writing it. 45 degrees involves this triangle. Sine, 1 on root 2. Multiply top and bottom by root 2, and we get root 2 over 2. Cos of 45, adjacent over hypotenuse. So that's also root 2 on 2. And the tan of 45 is 1 over 1, which is just equal to 1. 60, triangle up here on the left, sine of 60 will be equal to root 3 on 2. Cos of 60 will be a half, and the tan of 60 will be root 3 on 1. Alright, so that generates all of this table by just memorising. So let's just put a big circle around that. You need to memorise those two triangles to be able to work out sine, cos and tan of 30, 45 and 60. Now, this is in degrees. We need to probably be able to memorise these two triangles with radians as well. So 30 degrees equals, to convert degrees into radians, we multiply it by pi on 180, so that'll be 30 times pi over 180. And it is conventional just to leave the pi in it. 30 into 180 goes 6, so that's just pi on 6. 60 degrees will be 60 times pi on 180. And 60 goes into 180 3 times, so that'll be pi on 3. And 45 degrees will be 45 times pi on 180. 45 goes into that 4 times, so that'll be pi over 4. So instead of just remembering this table with degrees in it, theta can equal, now 30 degrees is pi on 6, 45 is pi on 4, and 60 degrees is pi over 3. So the tan of pi on 6 is equal to pi on 6, tan will be root 3 on 3. So if you like, not only remember those triangles like that, but you can also memorise it with pi on 6 up here. So we'll do that in another colour. And this is pi on 3, and this is pi on 4. So memorise them both with degrees and radians in there.